Okay, so now we'll move on to the next part of our lesson in integration. So we are going to learn how to find the length of a curve. Okay, so this is something quite new. So you are going to learn how to find what the length. When they give you a curve, you find actually how to find the length. Now previously you have learned how to find the area under the curve, isn't it? And you have learned how to find the volume generated when you rotate 360 degrees around the x-axis. You have learned how to find the volume. But this is something really new. What are we doing here? We are learning how to find the length of the arc. We are learning how to find the length of the arc of this curve. Because they are giving you, you don't need the proof. All you need to know is to know the formulas. So these are the formulas that they are introducing you. So the first one is the arc length of the curve is given by 1 plus dy by dx whole thing square. The root of this with respect to x. Let's write it down. So the arc length S equals, this is the arc length, okay? So the arc length is given by 1 plus dy by dx whole thing square. The integration limit they've given XAXB. What are XAXB? So basically XAXB means if you take a graph and let's say this is the arc. Okay, so this is my arc, starting point A, starting point is B, ending point is B. So basically XA means the X value at the starting point. XB means the ending value coming at the ending point. Okay, so when you give your integration limit, you set the place where the arc is beginning and where it's ending. And then basically you will get the length of the arc in between A and B. You get the length of this line. You get the length of this curve, okay? So the equation is 1 plus dy by dx whole thing square with respect to x. Also, there's an alternative equation that they've given you. The integration, you can do this with respect to y. 1 plus dx by dy whole thing square, and this is with respect to y. So obviously when you are doing with respect to y, we will input the y limit. So it's going to be ya to yb. Ya to yb means you put off the starting y value and the ending y value. So this is again this is xa xb. Put it properly. My point AB. So this is xa xb. Point A and its point of B. And this is y point of A. This is the y point of B. Okay. So then you can see in here the arc length. We can find the same arc length by using this formula. 1 plus dx by dy whole thing squared. You see the difference in the two equations. The earlier one was dy by dx. This is dx by dy whole thing squared. And the integration is happening with respect to what? With respect to y. Then there is one more equation, because you know that we all, when it comes to these kinds of stuff, we also go for parametric, isn't it? Even in for area and for volume, we learn how to find the volume and area by using parametric equation. Similarly, even in the arc length, we learn how to find the arc length by using parametric equation. So write down this equation as well. The equation is integration of x by dt square plus dy by dt square with respect to what? Now it will be with respect to t. And your limits are t to tb. Okay, so these are the t limits. These are the three main equations that you need to use, and it's in I think mainly it's easier to go with respect to x basically. So the main equations that I believe is useful to you is the first one and the last one. If the equation is given in parametric form, use the last one, and if the equation is given in the normal Cartesian form, it's you can use this one. So anyway, just use whatever is the easiest to simplify, whatever is easiest to find the dy by dx, or if it's dx by dy, then go with that. Okay. Exercise 4G, question number 1. Find the length of the arc of the curve with equation y equal 1 over 3 x to the power 3 over 2 from the origin to the point with the x coordinate x equal 12. So from the origin means, what do you understand? Origin means your x coordinate is 0, and then you can see your ending point is x equal 12. So you don't need to draw it. You can understand what your limits are. So what is the arc length equation that we are going to use? S equals integration 1 plus, what is the easiest one? I think it's easy for us to find dy by dx, right? So I will use dy by dx whole thing square with respect to x. And the x limits are from the origin to the point with x coordinate 12. You understand? Shall we find dy by dx? So I get here y equals 1 over 3 x to the power 3 over 2. And then dy by dx will be, let's differentiate 1 over 3 into 3 over 2 x to the power 3 over 2 minus 1 is 3 over 2 minus 1 is half. So 3 and 3 cancels. I get dy by dx equals half times x to the power half. Okay, so let's input the value now. 1 plus dy by dx is half x to the power half. So we should square the whole thing. So what happens when you square? How do we get here? 1 plus 1 over 4 x to the power half. When you square, it's going to be x with respect to x. So basically, this is actually s equals integration from 0 to 12. I can rewrite this as 1 over 4x plus 1 whole thing to the power half, right? So what is the integration rule that we are going to use? So you know you have your P4, P3 integration rules, right? So what rule are we going to use to come do this? So then, to get the arc length, S equals to, so the integration gives me 1 over 4x. So basically, it's rule number 1. We have taken the rules for P4, P3, P4 integration. So we are using rule number 1 here. X plus b to the power n is 1 over a. Ax plus b to the power n plus 1 over n plus 1. So I get here integration from 0 to 12. I mean, I can take 1 over 4x plus 1. Okay, so the a value here is 1 over 4, isn't it? So then when you integrate, you're supposed to get 1 over a, which means what? This is 1 over 4. Because it's 1 over a, your a value is 1 over 4. And then 1 over a plus b to the power n plus 1. Add 1 to the power, your power is half. Half plus 1 divided by half plus 1. Can you all simplify? We need to put the limits on. So first we'll simplify, then we'll put the limits. So here 1 divided by 1 over 4 is actually 4, right? Half plus 2 is 3 over 2. And I get here 1 over 4x plus 1 to the power 3 over 2. 4 divided by 3 over 2 is 8 over 3. 1 over 4x plus 1 to the power 3 over 2. I have to put the limits. I still did not use my limits. My limits are from where to where? 0 to 12. Let's use our limits from 0 to 12. So x equals 8 over 3. 1 over 4 into 12 plus 1 to the power 3 over 2 minus the second limit. Replace all the x values with 0. 1 over 4 into 0 plus 1 to the power 3 over 2. What do we get here? 8 over 3, 1 over 4 into 12 is 3, right? 3 plus 1 is 4 to the power 3 over 2. Minus 8 over 3, 1 over 4 into 0 is 0 plus 1. Okay, so then what do I get here? 8 over 3 into 4 to the power 3 over 2 gives me how much? 4 over 3 minus 8 over 3, which ends up giving me 66 over 3. So this is the arc length of the curve. Okay. Okay, question number 6. The curve C has equation y equal 1 over 4 times 2x square minus ln x, where x is greater than 0. The points A and B on C have x coordinates 1 and 2 respectively. Basically, they have given you the xa and xb. Show that the length of the arc from A to B is 1 over 4 times 6 plus ln 2. Okay, so what do we do here? Basically, I'm going to differentiate this. I'm using the first equation, the same one I used earlier. So I'll be differentiating. I want to find dy by dx to input into this equation, isn't it? Shall we find dy by dx first? So how do you find dy by dx here? Y equals 1 over 4 times 2x square minus ln x. So let's get dy by dx. How do we get dy by dx? 1 over 4 is a constant. Let's leave 1 over 4 out. Differentiate. 2x square differentiation is 4x minus ln x differentiation is 1 over x. So this is our dy by dx. Now, let's apply the arc length equation. S equals integration root 1 plus dy by dx whole thing square with respect to x. And your limits are from where to where? Your limits are from 1 to 2. S equals integration limits are from 1 to 2. Let's input the values. Dy by dx is 1 plus 1 over 4 times 4x minus 1 over x. Power 2. Okay, so let's input this now. S equals integration from 1 to 2. What do we get when we simplify inside? 1 plus 1 over 16 4x minus 1 over x square, isn't it? Yeah. Okay, so we will able to simplify this. 1 plus 1 over 16, shall we open the bracket? 4x minus 1 over x square means 4x minus 1 over x into 4x minus 1 over x. Can you simplify the bracket immediately? 16x square, 4x into minus 1 over x, so you'll have to put a minus and then double it. You multiply these two terms and take twice of it. 4x into minus 1 over x is minus 4. And then that times 2 is 8. And then the minus 1 over x unit square, you get 1 over x square. Respect to x, okay. So then let's open the bracket here. S equals integration. Shall I take the common denominator here? So I get here root, this is 16 plus 1 times 16x square minus 8 plus 1 over x square. The whole thing divided by 16. This is okay. I took the 16 as a common denominator. Do you realize what I did here? So you understand I took 16 as a common denominator. Then that 1 over 16 I can take off of the root. Comes out as a 1 over what? 16 comes out as a 4. Do you agree? 16 comes out as a 4. So then inside the root I have 16 plus 16x square minus 8 plus 1 over x square. Is that okay? So I end up getting here. Inside the root, what do I get? 16x square plus 16 minus 8 is plus 8 plus 1 over x square. Okay, so we come to this point. Our limits are from 1 to 2. Okay, now what? Now I have simplified this to the fullest. This is the maximum I can simplify. Okay, now what do we do? Done. So how do we proceed from this step onwards? Now you can see we can't use any of our normal rules. They don't work. So what you need to do here is, now did you notice the kind of bracket that you expand at the beginning? Look at this bracket you expand at the beginning. You expanded 4x minus 1 over x, right? And you notice you got 16x square minus 8 plus 1 over x square. You see the expansion of 4x minus 1 over x gave you 16x square minus 8 plus 1 over x square. And do you see that there's something quite similar to that over here? There's only one small difference. What is it? The minus 8 has become plus 8. So can't you recommend the kind of the square bracket that you think should come over here? 4x over x, the square. So what happens in 4x 1 plus 1 over x? 4x plus 1 over x. Now these are things you need to realize. I mean, you need to have a little bit of practice, and opening this bracket should give you some insight, because this looks a lot like the other one. What we open here, what we got here looks quite similar, just the difference in the sign. So when I try this, I get here 4x into 4x is 16x square. 4x into 1x is plus 4. 1 over x into 4 is plus 4. 1 over x into 1 over x is 1 over x square. So don't we get that particular term? We get the answer, right? 16x square plus 8 plus 1 over x square. You see? So then this is the square of 4x plus 1 over x whole thing square with respect to x. And your integration limits are from 1 to 2. Then the root and the square will obviously cancel out. And what do we have here? 4x plus 1 over x. The integration of 4x plus 1 over x. Do you see? The square and the root cancels out. Okay, now we can integrate, right? This is a normal function. This is something that we can definitely integrate. So when I integrate, what do I get here? X integration is 4x square over 2. And what is the 1 over x integration? 3. 1 over x integration is ln x. And your integration limits are from 1 to 2. Input the limits. 1 over 4 times 4 into 2 square divided by 2 plus ln 2 minus, put the second limit, minus 1 over 4. 4 into 1 square over 2 plus ln 1. ln 1 will be 0. Yes. So 4 into 2 square, that is 2 square is 4. 4 into 4, 16 divided by 2, 8. Plus ln 2 minus 1 over 4 into 4 divided by 2, right? 4 into 1 square is 4 divided by 2 is 2 plus 0. So simplify this. 1 over 4 into 8 is 2 plus 1 over 4 ln 2, right? Minus 1 over 4 into 2 is minus half. Then 2 minus half. How much? What does it give us? 2 minus half is? Yeah, 3 over 2 plus 1 over 4 ln 2. This will show that they've taken the, in the show that they've taken the 1 over 4 out. So, if you're taking 1 over 4 out, what does it mean? You're multiplying inside with 4. Okay, so when you take 1 over 4 out, it means you are multiplying the inside terms with a 4. 1 over 4, you take 1 over 4 out, means you are multiplying by a 2. So I get here s equals 1 over 4 times 2 times, 3 over 2 into 4 gives us 6 plus 1 over 4 and 4 cancels. So I get ln 2, which is the show that for arc length. Is it clear?
Right.
Question number 10. The diagram shows the asteroid with parametric equations. X equals 2a cos cube t, y equals 2a sin cube t, and t values are between 0 to 2 pi. Okay. Find the length of the arc of the curve AB and hence find the total length of the curve. Okay, they are asking you to first find what? The arc length of the curve from where to where? The arc length of the curve AB. So first we'll find the arc length of the curve AB and then we'll move on to the whole. I think you can see AB arc length. If you find the total length of the curve is just multiply that by 4. Then let's find the arc length. Now you can see clearly this is what? Parametric, because x equal to a cos cube t, y equal to a sin cube t. Sin cube t, basically your x and y are separated. So it's definitely parametric. So what do we get here? What's the equation for arc length in this situation? Integration dx by dt squared plus dy by dt square with respect to t, and your t limits from ta to tb, isn't it? Okay, the two we have the two t limits. Okay, now first thing is let's get dx by dt. So my x equation is 2a cos cube t. How do I get dx by dt? Differentiate with respect to 2 and a is a constant. So cos cube t, how do I get it? The 3 comes forward, right? Cos t to the power 3. The first you give priority for the power. The 3 comes front and you get here what? Cos t to the power 2. And then into cos differentiation is negative sign. Negative sign. So then let's differentiate dx by dt equals minus. I'll take the minus in front. 2 into 3 is 6a cos square t into sin t. Is that okay? Then y equals 2a sine cube t. Let's get that also. So dy by dt equals 2a sine cube. Also again you give priority for the power, right? The power 3. You take the power 3 in front. Sine t to the power 2. And then into differentiation of sine, which is t. Here dy by dt equals 6a sine square t into cos t. Okay, so I get this. Now it's time to input these equations, and the other thing is we need to get our t limits, by the way, because you can see here they've given us the x. I mean, like I have my x limits. I need to make sure I find my what limits. I have to get the t limits. Now when you're normally integrating, what are the x limits we would use from a to b? The starting x limit would be 0, right? And the ending x limit would be here 2a. Okay. The starting x value here is for this part, for the AB part of the curve. The AB part of the curve, the starting limit is x0, the ending limit is x is 2a. Is that okay? Then when x is 0, let's get the value. So when x equals 0, what's the t value? 0 equal 2a into cos cube t. So I'll take the 2x to the other side as division. 0 divided by 2a is 0. Cos cube t, and then remove the power 3. So cube root of 0 is basically 0. And then cos inverse of 0. What's the first? Get the very first value. Cos inverse of 0 is 5 over 2. Okay. Half pi. And then when x equals to 2a, what do we get? 2a equals 2a times cos cube t. 2a cancels, right? 1 equals cos cube t. Cos t equals cube root of 1, which is 1. Then cos inverse of 1, 0. Basically at a, your t value is pi over 2, isn't it? And at b, your t value is 0. Are you with me? Shall we input the values now? So I'm use the limits from 0 to 2a. So basically 0 to pi over 2. That's correct. Did I do it correctly? Yeah, when x is 2a, t is, sorry, I had to correct this, right? Yeah, when x is 0, t is pi over 2. And when x is 2a, t value is equal to 0. Let's input the equation now. Input the values to the equation. Arc length S equals integration root dx by dt square. So what's my dx by dt? I think you can see we have minus 6a cos square t into sin t into the power 2 plus 6a sin square t cos t. With respect to t. So let's simplify this. What do we get here inside the root? Minus 6a square gives you 36a square, isn't it? Cos to the power 40 sin square t. And the other guy is also 36a square sin to the power 40 square t with respect to t. Then what we'll do is from the integral sign, let's take, there are two terms, take the common thing off. That's the best thing to do. What's the common thing? 36 is common to both the terms. Then a square is common. Is that all? Cos square and square t and sin square t is also common, right? The remaining 36 a square, sin square t, and when a cos square goes out, one more cos square t remains inside, plus 36 a square cos square and sin square goes out, another sin square t is remaining in here. Do you agree with me? What do we have here? Who is cos square plus sin square? Cos square plus sin square is 1. So I get here f equals to the integral of I think you can see here inside the integration, I have 36 a square, cos square, sin square. Basically, everyone is a square. Can't I take it out? I can take everyone out. 36 becomes 6, a square becomes a, cos square becomes cos, sin square becomes sin with respect to t. Do you understand? So how do I integrate? Integrate something called cos t sin t? What is the strategy? What is the method that I need to use here? Yeah, how do we integrate? Yeah, what is the rule that we use here? Okay, so now let's integrate 6a cos t sin t. How do we do it? So what we do here to integrate cos t sin t, we use the double angle rule, isn't it? So what's the double angle rule? We know sin 2t is equal to what? We say sin 2t is equal to 2 sin t cos t. Are you with me? Yes. With 6 I can break it off and I can write integration 6a, I can break it down as 3a times 2 cos t sin t. Do you agree with what I write? So 6a is 3 times 2 and then the 2 cos t sin t is the sin 2t. Here, let me take 3 out, I get here sin 2t with respect to t. Okay, so then what happens when you integrate sin 2t? Sin integration is minus, right? Minus 1 over 2 cos 2t. By the way, we had put our integration limits. I did not put the limits. What are the limits? So for x, well, normally the limits x0 to x2 is. So what was the t value when x is 0? When x is 0, what was the t value? T is 5 over 2 into 0. Then when x is 2, t value is 0. So 5 over 2 to 0. Okay, not the other way. Okay, so then our limits are from 5 over 2 to 0. Shall we input the values? S equals 3a times minus half cos 0, isn't it? Cos 2 times 0, then minus, again in the middle there's compulsory minus mark here, then 3a times minus half cos 2 times 5 over 2. So what do we get here? Cos 0 is 1, which means I get minus half here. Do you agree? Minus 3a into half cos pi is how much? Cos pi is minus 1, isn't it? Minus half into cos pi is minus 1. Is that correct? You get the answer here? So I get here s equals minus 3a over 2 and here I get s equals, here minus minus is a plus. So minus 3a into plus half is again minus 3a over 2, which gives me s equals minus 3a. Okay, however, there is one issue now here. I've given a negative arc length. I think it's mainly because of the way I've used the limits. Okay, so we know arc length is supposed to be what? It's a length. It's supposed to be positive. So my arc length is gonna be 3, not negative 3. I think we can input this problem here by changing the limits here because they've told us to get arc length BA. So we have here, so instead of taking s negative 3, s is the arc length, it should be positive. So then the arc length AB, I got the arc length AB as 3A. I think you saw the entire figure had 4 arcs, which means the total arc length is 3A times 4, which is 12A. So once again, the thing you can do here is because they said arc length AB, okay, they've said arc length AB. We can use here TA, TB limit, which means we can go, instead of going in this manner, we can go from 0 to pi over 2. If you use 0 to pi over 2, you will immediately get the positive 3A. Okay, so then even if I use the other way, I get negative. So it's fine. Just make sure since it's the arc length that you get the modulus of it. Okay, fine. Then let's move on. Let's start question number 15. 15 part A. Denoting the length of one complete wave of the sine curve with the equation y equals root 3 sine x by L. Show that L equals, this is the answer. L equals 4 times this integration. Okay, so let's get this show that. 15th one part A. Denoting the length of one complete wave of the sine curve with the equation y equal root 3 sine x. Okay, so they want you to take the length of one complete wave. In the sine graph, from where to where do you have one complete wave? Starting from 0, you go to pi and then 2 pi. I think you can see one complete wave is when you go from the 0 to 2 pi. So they are asking you to show they get to show that in this manner. Do you see the limits they've used in this show that? Have they used 0 to pi for the arc length? No, they've used 0 to pi over 2. 0 to pi over 2 is somewhere over here, right? And then that means they've taken how much of the arc length? They've taken 1/4 of the arc length. And then do you see the outside 4 here? So that means they take 1/4 of the arc length and multiply it by 4. And then you have to get this, show that. You're not supposed to, they're not asking you to integrate here. They're just asking you to get this, show that. So can you all get this, show that? So arc length, this is given y equal root 3 sine x is in parametric, it's in Cartesian form. Directly in Cartesian form, so I get 1 plus dy by dx whole thing square with respect to x, and my limits are going to be from 0 to pi over 2. Is that okay? So what do we get here? Dy by dx should be found first. So y equal root 3 sine x. So dy by dx is equal to root 3 sine differentiation is. So let's input the values. One plus dy by dx is root 3 cos x whole thing square. One plus 3 cos square x with respect to x. Is that okay? Yeah. So, okay, so we got to show that, right? 1 plus 3 cos square x, I got to show that. So this is not the full arc length, this is a quarter of the arc length. To get the full arc length, I should multiply this answer with 4. So it's 4 times. So I get a 4 times, and this is the show that. Okay, they are not asking you to integrate, they are just asking you to get the show that. Okay, is it clear?